For homework number 7, you will be looking at how to predict products for chemical reactions. Up until this point, I've given you the product to the chemical reactions, but now you're going to learn how to predict what the products are. The first step for this homework is to read the skit and try to understand it, and then after the skit, do the follow-up questions. Pause the video now and do the skit and the follow-up questions, and then come back to the video for a little bit of instruction when you're finished. There are 2 steps to predicting the products of a chemical reaction. The first step is to rearrange the ions, and then the second step is to determine the solubility, to see if a reaction even happens. A reaction will happen when a solid is formed. I'm going to show you a salt reaction in action. For this first reaction, I'm going to react sodium hydroxide and iron nitrate. Whenever you're doing a salt reaction, the first thing that you need to do is make the salt soluble. So I'm going to take a little bit of salt here. You can see that my salt has this kind of yellowish hue, and I'm going to put it into this test tube that already has distilled water in it. So I'm going to kind of carefully get it in there. And you can see that it turns this nice yellow color. I'm going to put that down for a minute. Cap up my salt. This is called a vortex. It will agitate a salt solution and make it aqueous. I know that iron nitrate is a soluble salt because on my solubility table I can see that. So if I push down, it'll start to vibrate as I turn it up, shaking it until I can see the salt kind of moving around. It's going to dissolve my salt. And you can see now there are no salt crystals in there. This is completely dissolved. Next salt I'm going to use is sodium hydroxide. Take a little bit of salt here, put it into my test tube, maybe a little bit more. There we go. Cap up my salt solution. And again, vortex. And my salt is completely soluble. So now I have 2 soluble salts, sodium hydroxide and ferric nitrate. This is iron nitrate. Ferric is 3+. And if I react these together, these are my reactants, they will do something maybe. So I'm going to do that in here. I'm going to pour a little bit of sodium hydroxide first because you always start with aqueous salts. You can see in the bottom, and I'm going to hold it up. And when I pour in my ferric nitrate, you should see something happen. Woo! Look at that. I'll mix it up a little bit, and you can see that it got really murky, really opaque, and it made on the side here, you can see the salt. This made an insoluble salt. These 2 salts reacted to make an insoluble salt. And I can predict what the products are of this reaction by looking at a chemical equation. So this made an insoluble salt, and I know because it turns murky. And if I let this sit here for a little bit, it should separate out. So I'm going to let it sit. And I'll show you the next salt reaction. So now I'm going to take potassium carbonate and I'm going to put that into this one. It has water in it. Okay. Cap up my salt. And again, vortex. And there we go. That is a soluble salt. There are no more salt crystals in here. And in my other test tube, I'm going to react my sodium hydroxide with my potassium carbonate. And you can see that nothing happens. These are both soluble salts that are formed. Sodium carbonate and potassium hydroxide are also soluble salts, so this will not form like this. And you can see it's starting to separate there. See, I've got the water line on top and the solid moving towards the bottom. That's called a precipitate because it is precipitating out of solution, kind of like rain falls out of the sky, precipitation. So it will fall down and collect at the bottom, and above it will be the aqueous salt that is left over in the reaction. So in this case, what's on the bottom is ferric hydroxide, and what's at the top in the solution is sodium nitrate. Sodium nitrate is a soluble salt. Ferric hydroxide is an insoluble salt. There it is. Okay, now that we have seen the visual reactions, let's do the work on paper. In one test tube, I had sodium hydroxide, and in the other test tube, I had ferric nitrate. Both of these solutions were aqueous. They are soluble, and as we saw, they create clear solutions. I mean, they're transparent. That's what clear means. See-through. Ferric nitrate was also aqueous, but you saw this was a yellow solution. A yellow, clear solution. Transparent, meaning there's no salt in there, but it had color from the iron. And when we put those two things together into their beaker, we got this really murky salt that kind of settled out to the bottom down here. And that was the ferric hydroxide. And above it were the sodium ions and the nitrate ions, because they don't form an insoluble salt. Let's look at the chemical equation for it now. Sodium hydroxide plus iron nitrate This is where the predicting part comes in. There are only two other products that these salts can rearrange into, and that is because positives have to go with negatives. We have Na plus, OH minus, iron 3 plus, and I'm going to draw one nitrate just for demonstration purposes. Positive has to go with negative, so the only other option for rearranging is like this. And that's what we got. Make sure that when you are writing the products over here, you're not carrying over the subscript. What the salt formula is over here is solely dependent upon the charge of all the ions on their own. You have to consider the ion charge when remaking the salts into new pairings. Next step here is to look at the solubility table and determine which of the salts was insoluble. What you'll find is that the ferric hydroxide is insoluble and the sodium nitrate is soluble, like that. Last but not least, requires some balancing. And if we balance, it'll look like this and that. And now it's balanced. This created a solid product. This is how you have to write the products. So when you're given an equation that is just the reactants, rearrange them with the other negative ion or positive ion, check the solubility table, and that's the product. So if we look at the second experiment I did, where I mixed sodium hydroxide and potassium carbonate, which we saw were both aqueous, they did not produce any insoluble salt. So you can rearrange them like this. And denote that they are both aqueous. You should still rearrange the salts into new products to check and make sure that they are both soluble, and you should do that every time, because oftentimes you won't be told whether or not the products are soluble or insoluble. Okay, you should be able to do part 3 now.